Hi, and welcome to the 10 square meter workshop. In the previous two episodes, I built all the hardware for my RouteMaster automatic digital router system. And now it's time to bring it together with a controller, for which I'll be using an Arduino, a cheap and accessible system, along with a TFT color touchscreen. So let's get started. This is a block diagram of the whole system. The items marked with a red circle are all available commercially. This only leaves the level changer and the 12-volt motor driver to build. The motor driver I covered in part 1 of this series. That leaves only the level changer, which I shall deal with later in this episode. The processor I shall actually be using for this project is the Arduino Mega. This is for a couple of reasons. One, the TFT display shown is a parallel connection and steals all the connections from Uno, so you need the extra I/O. Secondly, the 32K of a Uno rapidly gets chewed up when the libraries for driving the screen are used. And if you're going to have a lot of routines, you need more memory, and this one gives you 256K, 8 times as much. To measure the height of the router, I'm using a device like this. As you can see, as the slider moves, the reading changes on the screen. There's actually two lots of electronics in here. The first one reads the scale and sends out a digital signal, a string of bits, 24 bits long, to show what the position is. And the meter part merely interprets this and displays it. My router already has one of these attached, so I'm bypassing it and attaching an Arduino Nano. As you can see, I've had to use level shifters because the signal from the sensor is only 3 volts. The Nano is already attached to my computer and displaying readings on the screen. And as you can see, as I turn the router, the numbers change. Yep, that all looks fine. Proof of principle. This allows me to finalize the design of the level shifter. This takes the 3 volt signal from the detector and gives 5 volts for the Arduino. It also drops the 5 volts to 3 volts as a power supply. To hold the Arduino, I 3D printed this case. It pivots around this part, and you can just see the cable entry here. It's a fairly good fit in the case. I have the USB port sticking out. This will allow me to add further apps by just connecting it to my laptop. To connect it to the rest of the equipment, I'm using this old serial port cable from a PC. Remember those? I pushed the cable through, soldered on a header plug, then fed it mostly back and added a cable clamp. All buttoned up, it looks like this. This is the small circuit board it plugs into. This also has a level shifters on it and a socket for the linear scale to plug into. You'll see I've crossed out the 5 volt regulator. That proved to be inadequate. With everything mounted in the case, it's now time to wire up. At this point, testing could begin. I now found that the 5 volt regulator was getting a tad warm, so I replaced it with a buck circuit. Here. Fortunately, there was room for it. No mounting holes, so I tie wrapped it in place. Here's the fence moving in jog mode. And the router table. The software consists of a number of interlinking screens. This is the home page. You press the appropriate button and it changes to the function. This is the manual move screen. But I shall cover this more in the next episode while I demonstrate the system. I shall be publishing all the software for my RouteMaster on GitHub, so you can obtain it there for free. You may need to adapt it to your particular hardware, but basically you will have a working system. I then spent some time replacing wires with plugs and sockets, on the basis if you can take it apart, you'll never need to. If you can't, then you will. A mesh cover was then fitted to keep the dust out. The zero detection plate consists of another piece of corian with a block of aluminium let into it. The glue's now dry, so I'm going to mill it flat. I took a skim cut across the entire surface to establish this flatness. Add a lead-in plug and it's good to go. The control module just swings out. Touch screen ready to go. When it's needed for support, the mitre guide runs smoothly and accurately across the fence and removes easily when not needed. I was originally going to connect the overhead dust extraction to my overhead system and have the other one in the normal way, but this would have required a lot of modifications. So I ended up taking the underneath extraction through a side port, so they're coupled together as they were previously. When not in use, the hose is stored on brackets on the back. And finally, don't make anything for your workshop for which you don't have a home. I now have an extremely accurate automatic router table, and I can add many more joints, miters, box joints, dovetails, mortises, as many as I care to program. So now we have a working router table. In the next issue I shall be covering the operation of this and demonstrating it, but for the moment, bye for now.